Whoops. Oh no, we did this one.
Yeah, that's it.
A.m. to 10 a.m., the rate at which vehicles arrive at a certain plaza is given by, and I have this equation. I'm reading this the first time too, so I'm going to kind of write down some information I need here. A of t equals 450 square root sine. T is the number of hours after 5 a.m. I won't make that mistake again. I'll make sure. So if it's 0, then that's 5 a.m. and so on. I'm going to just make myself a note so I remember. A of t is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. Oh, how nice. And they give us the t values there. I bet everybody in 2019 messed up on that, and that's why now they define it and say. All right, from 6 a.m. t equals 1 to 10 a.m. So what am I going to do? I want total number of vehicles. Right now I have vehicles per hour. It says A of t. That's a bit confusing because it feels like acceleration, but it's not. So what do? Do the integral. That's exactly right. That's exactly what I would do. So I'm going to do the integral. It says write but do not evaluate. So I'm going to go from what to what? 1 to 5. And then I have my equation, 450 square root sine. You could just write A of t in here again. Don't forget that dt. I guarantee you wouldn't get points for that. All right, so scoring guidelines here, that is 1 point. That's all you have to do. You have to interpret? Wow, that was almost too easy. Scoring notes, because these are the kind of things that y'all keep asking me about, so I printed out the really, really detailed things. Must be a definite integral with correct lower and upper limits. A response missing dt or dx does not receive the point. So don't forget those. Adam, don't forget. Okay. If you write this incorrectly, you don't get your point. But if you write this, you do get your point. So be careful. It says a response with a copy error in the expression for A of t will earn the point only if it's also accompanied by this. So if you write the equation wrong, but you have this, you'd still get the point. But if you just write the equation wrong, you don't get the point. So let's say I accidentally write 0.62 and forget the t or something, you don't get the point. All right, let's look at part B. Y'all have questions about that? If this is boring and this is not going to help, y'all tell me. I don't know if it's better to have you, I don't know. I've not really ever talked through one, so. Okay, find the average value of the rate. Okay, so average value, clued in. What does average value mean? But how do I find average value? 1 over b minus a times the integral of that function. And it's the average value of the rate in vehicles per hour. So this is going to be of a of t dt. This is a calculator problem. So at this point, oh look, 1 point uses the average formula. You get a point for that. So I want to, this says from, same interval from 1 to 5. So 1 over 5 minus 1 times the integral from 1 to 5 of a of t dt. And I'm probably just going to write a of t dt. I'm probably not going to overcomplicate anything here. It's in the calculator, so this is your function integrate. Make sure you can do that. Make sure you get the right answer there and tell me what you get. So in y equals, you have y equals and you have that function, right? That function was 450 square root sine 0.62t. And math, We want to do the integral of y1 with respect to x from 1 to 5. Then we want to divide by 4. Yeah.
On the left, is it A to B?
Oh, it is. Sorry.
I just thought.
Yeah, sorry. It's A to B. My bad. Sorry. 375. So approximately 375. Remember how many decimal places do I need to go out for 3? So point what? 537 cars. If they asked you to interpret this, this is the average number of cars that leave the parking lot, arrive at the parking lot. Sorry, that's why it's A, arrive. The average number of cars that arrive at the parking lot between the times 6 a.m. and 10 a.m. Everybody okay? This is a 2-pointer, 1 point for the average value, 1 point for the answer. I feel like this is an easy one so far, knock on wood. They said that this was a hard FRQ last year, so we'll see. Let's get worse. Yes. Yes, I would definitely put, this one doesn't ask you to interpret, but if it did, you would definitely put between 6 a.m. and. All right, let's look at part C. Is the rate at which the vehicles arrive at the plaza at 6 a.m. increasing or decreasing? Give a reason for your answer. What am I going to do? The rate at which vehicles arrive. What do y'all think? Derivative. Derivative rate is always derivative. So find the derivative, and then you're going to evaluate at t equals 1. So really what I'm finding is derivative at 1, right? Again, this is a calculator problem, so let your calculator work for you. You've already got the equation in y1, right? So now instead of fn int, do the in deriv. So what do you get the derivative at 1 to be? So is the rate increasing or decreasing, and why? It's increasing. The rate is increasing because, and here you could say, I would probably say the derivative at t equals 1 is positive, or the derivative at this time is positive, or the derivative is greater than 0. Any of those would work. You get a point. You get a point for this, and you get a point for the reason. You might should write it out. On this one, no. I mean, if you do it with me right, if I did units, this would be cars per hour. Oh, yeah, I think. But maybe use what they use. Maybe use vehicles. I love the questions y'all are asking now because you're starting to get the feel of what it is they're looking for, how nitpicky they can be about something. All right, so that was a 2-pointer. Check out everything. Even if you got the wrong value for the derivative at 1, as long as you wrote this, you get a point. That's pretty cool. So knowing that you had to take the derivative even if it was wrong. All right, let's look at part D. A line forms whenever A of t is greater than or equal to 400. The number of vehicles in line at time t for, this must be my big one. Yeah, 1, 2, 3, 4 points. Is given by I spot a fundamental theorem problem. What clues me in as this being a fundamental theorem? This is what I see, this mixture of variables here. All right, where A is the time when a line first begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time interval between A and 4. Justify your answer. Thoughts? Let me read what they're asking me. Greatest number of vehicles in line. Greatest number in line. So a max of what? Max of n of t, right? Because it says, yeah, the number of vehicles in line at t is given by, so I want the max of n of t, which means if I want to find a maximum, I need to first find a derivative. Are y'all following me? And set it to 0, right? So if you reason through, keep going, because this one was kind of convoluted to start with. All right, so I need to find a derivative of n. Well, the derivative here, right? What do you do? What's it going to be? That's exactly right. This is, again, that fundamental theorem. Now what? Set it equal to 0. You get a point for setting it equal to 0. You don't get a point for doing the fundamental theorem, which is crazy to me, but you do get a point for setting it equal to 0. This is a calculator problem. Don't forget this is a calculator problem. So you can do one of two things. You can graph this, find where it crosses the x-axis. You can add the 400 and find where the function equals 400, but any of those, I would definitely use my calculator to find those values. So if you do, what do you get for t? I hear y'all clicking and plugging. Yes. No. AFT. Yes. 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 And so that should already be in Y1 for you, right? So just go in and put minus 400. Make sure you're in radians also. In fact, before you take that exam, double check your calculator. Make sure you're in radians and your batteries are good. I did a Zoom 7 on it, a Zoom trig. I see 2 zeros on here. What does it say? Yes, portion max. Portion biggest. We don't know yet. Right. You got 3.59877, something like that. To the nearest home. Okay, so these are my solutions here for t, right? These are my times. Let me reread this question. Oh, we're finding maximum, right? I'd probably do a sign chart. The derivative tells me what the function is doing. I got 1.469. I got 3.598. Here and here, looks like I go negative. If I use my graph, since it's already there, right? Yes, no, maybe so. So where's my maximum happening? But that's not what it asked me, because it asked me to the nearest whole number, find the greatest number of vehicles in line. So now I have to take that value and I have to plug it back in. So I do n of 3.598. Which is going to be, say again. So I'm going to go from, that's the derivative. So I'm going from A, which is 3.598, to T, which should be 4, right? Hold on, let me think about this one. It says a line forms on the view. I'm listening. Because that's your time, but what is your A? A is the time when the line first begins to form. A line forms whenever A of t is greater than or equal to 400. So yes, your t is 3.598. What did you put for when it first forms? Because we already solved that. Again, this is already in your calculator, so evaluate. Do your integral and evaluate. And remember that it tells you to find the nearest whole number. So what do you get? Four, six, nine. I got 71. Is that what y'all got? Nobody wanted to say it. 71. The greatest number of vehicles in line is 71. So it, yeah. Right. You're good. I think about it too, like if this is decreasing, right? So there's less and less cars arriving. So I had to read through it several times to know what it was that I needed to do. So it said um, the greatest number of vehicles in line, and then I had to go back and read. It says the number of vehicles is given by that equation. So I want to find a maximum of that equation. So to find a maximum, I know I need to do the derivative. So this was 4 points. Let me show you where you got your points here, because even if you didn't know where to go and you floundered, just like I did on that last bound, you still could have gotten 3 out of the 4 points. Yeah. So on theirs, I didn't see it justified. If I'm justifying this, I would say A is time to the nearest, I'll find the greatest number of vehicles in the line. I would just say that this is a maximum of N of t because the sign of the derivative of N of t changes from positive to negative at this value. Let's see how they explained it. They gave you a point for doing the derivative equal to 0. They gave you a point for finding the A and the B. In other words, that 1.46 and that 3.59. Oh, you know what their justification was? Instead of a sign chart, because here a couple years ago they stopped giving you credit for the sign chart being like the justification. They did a T chart. Theirs looks like this. And they did it for A, for B, and for 4, and they found all of these values. I would say it obtains the maximum value there because at this point it changes, but this does make a relevant point too, in that you need to check the endpoint also because it's a restricted domain there. Remember that extreme value theorem? Those maxes or mins could occur at the endpoints of a closed interval. So that was their justification. So if you don't want to put it in words, I'd probably put it in words just to find it a little easier. And then 1 point, of course, for the answer. That was a pretty hefty. So A, B, and C were pretty easy. D was a little bit harder, but I think you probably still could have gotten at least a point or 2 on D. Especially if you stuck by the write something, take a derivative somewhere. You'd have gotten a point. Yeah, find a 0, find a something. Something. Oh, they have a lot of write-up about part D. Okay. If y'all want to take a look at the scoring notes whenever we're done, you're welcome to. Defined by f of x equals the log of x plus 3. X plus 3, yeah. So I'm going to assume that this is f of x. I like to label my graphs because as I keep referencing them, I keep looking up and wondering which one's which. And then g of x equals x to the fourth plus 2x cubed. If you weren't sure, remember you have your calculator for this. The graphs of f and g are shown in the figure above, intersect at x equals -2 and x equals b, where b is greater than 0. Find the area of the region enclosed by the graphs of f and g. So the very first thing that I'm thinking is we need that intersection point, yes? So I would probably graph both of these on my calculator and go ahead and find that point of intersection. So let's do log x plus 3, and then let's do x to the fourth plus 2x cubed, and I'll just do, exponents. All right, I'm going to zoom standard here, see what's going on. I would try to keep them as much as you can, but it's not going to be wrong. 0.78197. I'm probably going to keep it at least out that far. 75. Yeah, so you can keep referencing them. And then anytime you type that letter, it'll do it like that. I'm glad you caught something useful like that. I forget to tell y'all some things like that. Oh, good. That's probably helpful. Find the area of the region enclosed by f and g. So the area here, enclosed by f and g, so top minus bottom, yes? So I'm going to do the integral from what to what? -2 to that b I found, right? So 0.78197514, or if you came at the beginning of the problem and said b equals, you could just keep referencing b. Just make sure you define it in that part. They're going to score what's in that part, yeah. I would probably keep until and don't round until the very end. So now I need to do top, which is f of x, minus the bottom, which is g of x, and do not forget your, what, Adam? X. All right, what do you get? One point for the integrand, 1 point for the limits of integration, your bounds, and 1 point for the answer. That was 3 points. It's a pretty easy 3-pointer. I don't know what they were talking about last year. It's pretty easy. No wonder everybody passed. Huh. Maybe so. All right, let's look at B. For this one, no. No. All right. I bet there's going to be a cross section or a revolution somewhere in here. Between -2 and b, h of x is the vertical distance between the graphs of f and g. I'm probably just going to go ahead and write h of x is the vertical distance between the two. Well, that's different depending on where I am, right? Do you see that? Is h increasing or decreasing at x equals? All right, well, let's find h of x first. H of x is two different things depending on where I am. Do you agree? Because from -2 to 0, right? Because you're going to subtract them anyway. So it's not going to matter. So it's just going to be f of x minus. You see why I stopped for a minute? See how that's below the axis? But it's still not going to matter because if you subtract a negative, it's adding it to it anyway. So it's not going to matter. So no, they're not different. So f of x minus g of x. And so now it says is h increasing or decreasing at x equals negative 0.5. So to know if it's increasing or decreasing, I need to find a what? A derivative. So I need the derivative of h, which since I'm subtracting, I just need the derivative of each one. But I need to find it at negative 0.5. Again, this is a calculator problem. Use your calculator. What happens? Yeah, I really wish these fancier calculators didn't put it in the notation. Derivative. Y2. I got negative 0.6. So what y'all got? Therefore, since, what did it do? Tell me to give a reason. Since the derivative at negative 0.5 is less than 0, h of x is decreasing when x equals negative 1 point for finding the derivative, 1 point for the answer. 2 points. Part C. The region enclosed by the graphs of F and G is the base of a solid. Here we go, their cross sections. Remember, volume is the area integrated. Yes? So yes, that's right. Okay, thank you. Cross sections of the solid taken perpendicular to the x-axis are squares. Squares are nice. I've also already found the distance between the two, right? The f of x minus g of x. So find the volume of the solid. All right, so volume would be the integrated area. So I need to find the area of each cross section. The area being the distance between, and it's a square. So it's just going to be that f of x minus g of x squared. Yes? So now I'm just going to do the integral from -2 up to that point that I found, that intersection point I found, which was what? Just, I would, I feel like yes. Yeah. Well, but even if you just write B, because B's been defined as the intersection of the 2 points, I think it's okay. Because they define B as being the intersection. So yes, I would say yes, so that's okay. And then I'm going to do f of x minus g of x squared, don't forget dx. Again, because this is a calculator problem, this is straight in the calculator. So integrate from -2 to 0.7819. Y1 yeah, don't do it. 5.340. I don't have any units, so I don't have to worry about that. I can just put 5.340. That was 2 points, 1 point for the anagram, 1 point for the answer. You see how they want you to rely on the calculator. If they let you use the calculator, make sure you are using it, because that's what it's there for. Oh, gross. Look at part D. Okay. A vertical line in the xy plane travels from left to right along the base of the solid described in part C. Wait. Okay. The vertical line is moving at a constant rate, so that tells me derivative of 7 units per second. Find the rate of change of the area of the cross section above the vertical line. Okay, hold on, I have to wrap my brain around this question. Vertical line left to right along the base of the solid. Vertical line is moving at a constant rate, 7 units per second. Find the rate of change of the area. If I want rate of change of area, my gut instinct is to say, take the derivative of the area formula. With respect to time. So what is this? Because area was f of x minus g of x, right? So if I were to take the derivative with respect to time, yes. So now if I do the derivative of this, it's going to be 2 times times. And then because I'm doing it with respect to T, I have to follow with that. Yes. What they did was a lot smarter than what I did. It's a calculator problem, so they just did the derivative. They did the derivative at negative 0.5 times dx dt. Times, yes, 7. Because it gives you the rate in there. It tells you that dx dt is 7. So if you do that on your calculator, what do you get? It'd be what? Oh. Well, you should have that equation in there. So this should be, it's technically it's all of this at negative 0.5. But I don't have to do all that because if you already have, I would put in y, in your y equals, I would put, like you've got a y sub 3, right? I would do y sub 1 minus y sub 2 squared. And then, because I'm not going to retype anything, I mean, you know what I'm saying? You've been referencing the same equations the whole time. Then what I would do is I would do my end deriv for y sub 3 with respect to x at negative 0.5, and then I multiply that by 7. Take the derivative and then multiply by 7. So let's see, y1 minus y2 that one, it was hard, I think. I got negative 1.325, and then I need to times it by 7. That's fine. You can have more, but you can't have less. So if you're scared, just keep going. Just keep going. All right, that one was hard. That one was worth, oh, come on. 2 friggin' points. And I thought that one was hard. Yeah, right. But, you know, it wasn't that it was so labor intensive, it was just wrapping your mind around what they wanted you to find. All right, one more and then we'll save the other 3 for later. Let's look at number 3. Non-calculator. Another shape. Last year's, that might be why they said it was hard. They hated areas and volumes last year. Do you? Yeah. I know. You talking about with respect to y? Right minus left. Yes. I always try try to do with respect to x effective. Because that's what you're so accustomed to doing, so you mess up less.
And if you're doing that, you have to change the.
Right. Right. So you'd have to solve the equation for x instead of y. All right. I feel like this is very, very, very similar to that 2019 test we took. A couple of these problems, anyway. Yeah. Ooh, this is so hot. It's burning. All right. Let f be a differentiable function with f of 4 equals to 3. That's probably going to be very important. This is the graph of the derivative. On the interval from 0 to 7, the graph of f prime, the derivative of f, consists of a semicircle and 2 line segments, as shown in the figure above. Find f of 0 and f of 5. All right, f of 0. How are we going to find that? We've got f of 4, so we're going to use that fundamental theorem. Yes? So if we do the integral, actually what we'll do is f of 4 plus the integral from 4 to 0. Since they gave us f of 4. Because, yes, so we're going to end up subtracting it. Well, here's why. So 4 is really from 0 to 4, right? But I don't have that. So what I'm doing is, I know f, you see what I'm saying? Okay. And what it's going to leave me with is the f of 0. Right. Right. All right, so f of 4, it told me was 3. And now I can, and actually, this is going to be minus the integral from 0 to 4 of f of x dx. Ooh, this thing's hot. So from 0 to 4, which is a semicircle, right? So the area of a semicircle, 1/2 pi times the radius here looks like 2. 2 squared is 4. 3 minus 2 pi. No. This is negative because it's under, so it becomes 3 plus. Yeah. It's under the, yeah. Yes. All right. F of 5. Again, same process. This is just testing that fundamental theorem. If you use the same thought process that you used for f of 0 and you use it for f of 5, I'm going to do f of 4 plus what? What's my integral going to run from? I want the 4's to cancel out, right? So this one's really going from 0 to 4. I want the 4's to cancel out and leave me with 5, so I'm going to put a 4 here. Does that make sense? Do you see how we're doing that? So now from 4 to 5 on my graph, I've just got this little piece of a triangle. how do you know the height? I think I'm going to have to do a little slope work. Let's see. It looks like, yeah, it's got a slope of 1 because you're up 1 over 1, up 1 over 1. So it's got a slope of 1. This means this point is just 5, 1. So height of 1 and base of 1. So 1/2. All right, so this f of 4 was what? 3. 3 plus 1/2 times 1 times 1. 3.5, 7 over 2, any of those work here. And believe it or not, this was 3 points. Bless you. Inflection on the graph. All right, so if I'm looking for points of inflection, what am I looking for? When the slope changes, that's exactly right because I'm looking at a derivative here. So I want to know when the slope changes, which is going to happen at maximums and minimums on here, right? And it says from 0 to 7. So what are my possibilities here? I would do a sign chart, by the way, too. What are my possibilities? Where am I looking at possibly points of, oh no, it doesn't say, it says all points of inflection. Oh, well, that's a lot easier. So no, you don't even have to do a sign chart. X equals 2 and X equals 6. Because it won't justify your answer. So there's my answer, which gives me a point. This one was pretty easy for A and B. Not going. Justification, because the sign of the derivative, wait, no. The sign, the function f prime changes from increasing to decreasing at these points, or from decreasing to increasing, depending on which one it is. I have to think about it. I have to wrap my brain around it. Starts getting hard when you start thinking about it. You got to look at what you're given. So at x equals 2, f prime changes from decreasing to increasing. Bless you. And at x equals 6, f prime changes from increasing to decreasing. That was a 2-pointer. One for the answers, one for the justification. Well, these last two must be doozies. Bless you. No, it's just part C, part B. Right? How many points is the first one worth? Part A. Part A was 3 points. You got a point for finding the area of either region, and then 1 point for each answer. So even if you didn't know how to do it, but you found the area, you get a point. It was pretty nice. All right, part C. Let g be the function defined by g of x equals f of x minus x. On what intervals, if any, is g decreasing from 0 to 7? Show the analysis that leads to your answer. How do I tell if a function is decreasing? Derivative, that's exactly right. So I'm going to find the derivative here, which is, yes? Now what? Say again? Set it equal to 0. I got a graph there provided for me of f of x, yes? Where is f of x1? It happens 2 places, 5 and 7, right? Do we all agree? 5, 7. I have my, what is my, from 0 to 7? So I don't need any of this. Negative, positive. Remember, I'm not looking at the derivative of f, I'm looking at the derivative of g, which is derivative of f minus 1. So everything's shifted down 1. That's why it's not quite lining up on the graph there. So the question was, on what intervals, if any, is g decreasing, and show the analysis. So I think that I've done a good job of the analysis. So where is it decreasing? It's decreasing on the interval from 0 to 5. No, that's not what they got. No, yes it is. Just, I'm lied. Yes it is. Graph of g is decreasing on the interval from 0 to 5. Because from 0 to 5, because g prime is negative on those intervals. All right, part D, last one. For the function d or g defined in part C, find the absolute min on the interval from 0 to 7. So I'm back with the same g. Remember, g of x was defined as f of x minus x. It says find the absolute minimum. I find a minimum by, and I've already done all this, right? I know where it equals 0. I've already done my sign analysis from 0 to 7. What was my 5? So what this one I'm sure is wanting you to do is to test the endpoints as well because of extreme value theorem, right? So what I need to do here is I need to find g of 0, I need to find g of 5, and I need to find g of 7. And you have to find each one of those in order to get all your points because you have to consider them all. Now look, we already found, so this is f of 0, is it minus 0? This would be f of 5 minus 5 because I'm just using that equation for g. We already found these two in part A, right? So f of 0 we found to be what? 3 plus 2 pi minus 0. All right. F of 5, what did we find to be? What is it? 3.5 minus 5, which would be 1.5. How about F of 7? We what? Yes. Sorry. Did we find F of 7? Can you find F of 7? I think we could. I think we could do the, we'd have to go back and do what we did in part A for F of 7, right? Let's see. It's not going to be, it can't possibly be 7 though. Why can it not possibly be 7? It starts increasing from there, so I don't even have to consider that. That's true, yeah. So it's got to be g of 5. I would say no, since, let me see. I would say this is the only one you need to show. But you really don't even have to test it. You're right, because of the way the endpoints go. Let's read what they put. Considers g prime of x equals 0 as a point, answer with justification as a point. G is continuous, the derivative is less than 0 on 0 to 5, and the derivative is greater than 0 between 5 and 7. No, they use extreme value. I mean, they didn't use extreme value theorem. They just said because it's continuous on a closed interval and between 0 to 5 is decreasing and 5 to 7 is increasing, 5 must be your absolute name. Yeah. Absolutely. That's what I was just fixing to say. Make sure it doesn't say at what x value does the minimum occur. It says what is the minimum value. So you'd have to plug that back in and find that negative 1.5 there, because that is the absolute minimum value. Bless you.